atomics, these are as follows. Number one, the position of the atoms in the binding site cannot be assumed to be precise as there. So this is the dilemma, that is, in the receptor there are these spaces wherein the amino acids have been entrapped, and these amino acids have got their own structure, their own stereochemical arrangement, their own configuration and conformation, which we cannot understand at the moment, while the lead compound which you have made first time to enter into it, and it could be able to fit into the amino acids as it is required. This is that process which is very difficult to understand. In general, a lead compound designed by a de novo technique must bind in a stable conformation. Now, what is conformation? You have to understand this word, this is the stereochemistry word, which is very important for the pharmacist, and it is the pharmacist who must know it. Conformation. Look at, if this is a compound, it is moving in this way. Each one is another compound, 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 and similarly is the case. So these are various conformations which are not to be understood easily by this route, what you call it as de novo drug design. Conformation, the synthetically feasible and to be flexible than rigid. This is the point. Herein, it's very difficult to have a flexible compound, and sometimes it's very easy to have a rigid compound, and rigid compound would not be able to give a very good drug, whereas the flexible form could be able to give a binding site properly, wherein it could have spaces like this, and these spaces could be able to have a pretty good response which is desired when it fit into the receptor site. That is important. That's why this method, what you call it as the pretty old method, is very difficult to elicit the response which a pharmacist needs, and which is the actual requirement and the demand of the body. For that matter, it is to be said that almost every year synthetically 10,000 compounds are being synthesized by the synthetic pharmacist, and out of that only one or two or three, or more precisely 4 compounds could be able to get the status of a drug. So that's why this technique is very difficult to understand, and per year 10,000 compounds are being synthesized in different area of the global village, and out of that only could be able to get 4, 3, 2, 1 the status of that, which act as a legend, and that legend could very accurately be fitted into the receptor site. That's why this de novo, a pretty old method, is very difficult, and that's why we have to move towards the most modern methods which are currently being applied in the global village, and dot techniques are there, and which is being extensively used to elucidate the structure of the lead compound or the legend which fit into the receptor site. Therefore, it is better to design a loose fitting structure in the first instance and to check whether it binds as predicted. This is as far as a de novo design can go, since it is now necessary to synthesize the target structure, bind it to the protein and obtain as X-ray crystal structure of the legend protein complex to see how the structure binds in reality. This is the point. The structure binds in reality. That is, when the receptor and legend bind here loosely. Now the technique which is being used to elucidate the structure is the X-ray crystallography. When X-ray crystallography is being done, and that would let you to know what is the actual structure and where is the amino acid and where is the amino acid and its amino group and where is the carboxylic group and how does those amino and carboxylic groups which are present herein fit into the molecule which is called as a ligand and you have made, and how does it will be flexibly come herein, and then you would be able to give the actual structure of the ligand. And again, it is a tedious task to get structure more and more synthetically, and it took a lot of time in the global village to reach to the actual drug design in a way that the lead compound could be able to get series of compounds which you are required having maximum to minimum and as well as middle activity or subdued activities of the response. Those are very difficult through this design. Once this has been established, molecule modeling can be used as previously described to improve binding interaction. Now, that is the point to be understood here. When this has fit in, now you can change functional groups here, 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 or herein, or you can design the molecule which you required. Herein you can get the help of the computer or the doc system, which is most modern one nowadays, which could give you the actual structure of the compound which is being incorporated into the receptor. And this is the last and least domain of a pharmacist, wherein he has to design a structure of the drug and has to produce the response which is desired. In the crystallographic structure, if structure of active binding site is slightly different from the mode and there is no room for flexibility, then a molecule then has been designed to be a perfect fit for the model, may not bind at all to the active binding site. It is possible that the design molecule may not bind to the binding site exactly as predicted. So this is the actual point number 2, where we should have to look into it. We have designed it, but it will not be able to fit in here. For that matter, we should have to try for it that there should be little space and room available in the areas where the drug has to combine to the receptor site. We should have flexibility. We should not have the rigidity like this. The flexibility is more important for that matter, and it's very difficult to cover this area, because why this flexibility should be there? Who would like to answer it? And I would like to answer it in a way that whenever there will be flexibility and stereochemical conformations could be able to fit into it. Otherwise this cannot be. When it is rigid, stereochemical drug will not be able to produce its response. And most of the drugs which are being used are stereochemically effective, D form, L form, like that. Those are being required herein. Thank you very much for today. This is